We are going to do a couple things today. We're going to take a couple quick notes on what an even and an odd function are, and then we are going to do a discovery activity about transformations of graphs. Which you guys have kind of worked with transformations of graphs in your parent functions before, so hopefully that will be familiar. So, first definition, an even function. An even function is symmetrical with respect to the y-axis. An even function has symmetry with respect to the y-axis. Definition. That's all it is. An odd function, and we're going to come back. I would leave a little bit of room, like skip a couple lines in your notes, kind of like I did, because we're going to come back and add some things in here. An odd function is symmetrical with respect to the origin. I have two graphs that I will show you, and we'll decide which one has which kind of symmetry. But first, let's just write it down. So even, symmetry with the y-axis. Odd, symmetry with the origin. I'm going to come back to this slide. What kind of symmetry does this one have? Y-axis or origin? Y-axis. If we fold it across the y-axis, it looks the same. So this is what we would consider an even function. What kind of symmetry does this one have? It has origin symmetry, so it would be an odd function. Okay? Excuse me. So origin symmetry kind of looks like we would have to fold our paper along both axes into quarters, so then they would overlap. Okay, so what appears in the first coordinate or first quadrant kind of gets rotated to the third, or maybe second to fourth quadrant. All right? But we kind of have that diagonal symmetry going on. Okay? So let's come back and talk about even functions. We have that y-axis symmetry. So this is what I want you to think about. If we have a coordinate x, y, and we have y-axis symmetry, what other coordinate is guaranteed to be on our curve? Negative x, y would also be there because of that symmetry. Okay, so what's happening? X and negative x have the same y value. Do you see that? X and negative x have the same y value. So for an even function, when we plug x into our function and get a y value, it is the same as plugging in negative x into our function and getting a y value. Plugging in x and negative x get us the same y value if we have y-axis symmetry. Okay. So here's our graphical definition, right? We have y-axis symmetry. This is our algebraic definition. Okay. Let's think about an odd function. If the coordinate xy is on our graph and we have origin symmetry, which other coordinate is guaranteed to be there? Negative x, negative y. So now this gets a little bit more complicated, right? We have a couple things happening. xy and negative x, negative y are both there. So if we replace x with negative x and y with negative y, our equation will remain the same. Okay? So algebraically, this is what happens. If we plug in negative x into our function, then we get out the same y value as f of x, except it's negative. So here's our negative x and our negative y. See that? If we plug in negative x to our function, we're getting the opposite of the y value we got before. So that's our algebraic definition there. Okay? So by looking at a graph, it'll be pretty easy to tell which ones are odd, which ones are even. Okay? The more challenging piece is when I give you an equation and I'm asking you to determine whether it's even or odd. Okay? What we need to focus on is if we get f of x and f of negative x to be the same, we know it's even. If we get f of negative x and negative f of x to be the same, then we know that it is odd. Is it possible for neither of them to work out? Yes, only special functions are even and odd. There are a lot of functions that are neither. Okay, so we're going to do a couple examples before we go to lunch. Okay, that is not the example. Here is the example. Okay, and I want to kind of show you how I'd like you to organize your work. Okay, and the more of these you do, the more you're going to kind of see some patterns. Okay. So some of you might even have an idea of what this is going to be, especially based on our parent function, okay? So I'm going to rewrite this here. Even means f of x equals f of negative x. And odd means f of negative x equals negative f of x. Okay, so the first thing, let's compare. We know that f of x is 4x squared minus 2. So now let's look at f of negative x. Remember, when we're plugging in, make sure you plug into x. So since x is squared, make sure the negative x gets squared. And then we need to rewrite it. When we square negative x, what happens? It turns positive, right? So this is 4x squared minus 2. Does that look familiar? That is what f of x is. So, since f of x is the exact same as f of negative x, we have an even function. Okay, f of x and f of negative x are the same thing, therefore we have an even function. That's what that will look like. Does that make sense? Excellent. Second example. I'll make it bigger. Okay. So f of x is x squared plus x minus 6. Let's compare that to f of negative x. Remember, when you're plugging in negative x, make sure anything you plug in, I would just always put it in parentheses, whether it's, just a negative x or a binomial like 2x plus 1 like we had in our other example. But you need to get in the habit of plugging things in for x in parentheses. So wherever there's an x, we replace it with negative x. What happens to negative x, the quantity squared? It's a positive x squared plus a negative x. Don't know what happened with that. I'm thinking ahead. Minus 6. Are f of x and f of negative x the same? No. Great. Since they are not, we know that this function is not even. I'm going to make a note. Okay. Now, our next option, maybe it's an odd function. For an odd function, we compare negative f of x to f of negative x. Well, look here. We already have f of negative x. Good. Let's try negative f of x. Negative f of x just means we take our function, put it in parentheses, and throw a negative out front. Putting it in parentheses is important, much like 10C on your quiz. That will be important. Okay. So negative f of x is negative x squared minus x plus 6. Does that match f of negative x? It does not. So f of negative x does not equal negative f of x, so it is not odd. And since it's not odd and it's not even, our answer would be neither. Here's what's important. You're using x's. You are not using any numeric values. You're using f of negative x. You're using negative f of x. Second thing that's important is that I showed all of my work to come to the conclusion of neither. Your algebra is, you showing your work with your algebra is kind of your verification that, yes, this is neither. Okay? On your gold sheet, this is your assignment. Okay, you have some that are bolded. Okay. I want to give you some instructions about our activity before I send you to lunch. Okay.